Okay, hi. Bryan here with MagVorTechs.org, and I'm here to shoot a introduction or preliminary video to a testing video I'm going to shoot on this machine here next. But first, we're going to look at this older machine here that was built back in 2001. Uses an identical magnet as the other machine. Let's back up here so you can see the two machines. This machine has a solid copper disc with an optical encoder on it. Solid copper disc. This machine has my invented disc, or my patented invention from 2003, which, let's pull it apart here gently, is far from solid. There are two discs. The other disc in there has 12 divisions. One of the parts came out. I'll repair that later. Set that back together. And it's interconnected through these rollers, these conductive rollers, that allows for this machine to have 24 radial elements in series inducted in front of this very large neodymium magnet. Whereas this machine has a single one. So in this video we're going to run this machine and measure the voltage at 1000 RPM. That'll be our reference. And here you can see that the machine was run back in 2001 or 2, and result was obtained of 0.042. So you can get in there and see that. 0.042 volts. Not very much. Okay, so let's turn on our tachometer, turn on our voltmeter. There we go, voltmeter reading 0.000, RPM 000, and then we add a 0 to the end of this, and that gives us our actual RPM. Multiply this number by 10, and that's RPM. So when this reads 100, it will be 1000 RPM. And we need a light source here for that meter. Okay, and we have our variac over here, power supply. And we're just going to measure the voltage across the radius of this disc at 1000 RPM. So, turning it on, whoops, a little too fast, 2000, back it down. That's pretty darn good. Running it steady. I'm going to let it be right there. Okay, and here's our voltage. 0.040 volts. Okay, maybe we can look at both of them at the same time. There we go. Right at 1000 RPM. 0.37, 0.38. I'm sorry.